conceptual part is back bonding, dimerization, inert pair effect, oxy acids of the p block elements, then the reaction that is of hydrolysis. This is again conceptual. इसमें आपको concept लगेगा. It is not कि आप सारे के reaction याद करने पड़ेंगे आपको. ठीक है. So there are few types of reaction जो इसके बारे में हम बता देंगे. Then you have these, all of these topics are what? These topics are conceptual topics. Then you have the structural topics such as allotropes, silicates and silicones, drying agent and bleaching agent, and then a big portion is reaction and compounds of group 13 to 18. Now in the reactions to compounds, देखिए hydrolysis एक ऐसा reaction जिसमें हम आपको समझा सकते हैं, and also in compounds oxy acids आपका हो जाएगा, right? So in the compounds oxy acids will be done, how to prepare oxy acid, and the reactions of oxy acid will be done, and also the structure of oxy acid will be done. So basically reaction में कुछ reaction ऐसे बचे रहेंगे आपके पास जो आपको याद करना पड़ेगा. Otherwise all the conceptual part we will be doing today, and then tomorrow we will be doing questions. So for the conceptual part I will be explaining the topics, and for the rest of these things I will give you notes, and then tomorrow we can discuss those things also, है ना, with the help of questions. Now moving on to the first topic, that is back bonding. Okay. Before back bonding, please first of all write this thing, that each group has a name, and then there is also something. For example, nitrogen family is known as nitrogens, oxygen family is known as chalcogens, and these are the valence shell electronic configuration. Valence shell means last cell electronic configuration. So you have NS2, NP1 in the group 13 till NP6 in the group 18. So you, from here you can see that NS2 is always there in the valence shell, and the electron is getting added in the p subshell. That is why these elements are placed in the p block element. Okay, these are placed in the p block. So the electron, the last electron जिस p subshell में जाता है वो इसी block में हम उसको रखते हैं. Okay, so we have NP1 to NP6. Now all of these elements, they can show variable oxidation state. They can show oxidation state using this one electron of p, or they can use both of these electrons from S and p. So for example, if I talk about group 13, तो group 13 में दो valencies हो सकते हैं, +3 and +1. Both are possible. If only p is giving electron, that means it will be +1. If S and p both are giving electron, that means it is going to be +3. Okay, we'll talk about that also, which is more stable where. But these are the general ideas that you should have. The variable oxidation state also. Please write this down. Let me know once you're done. Done everyone? Moving on, back bonding. Please see, first of all, what is back bonding? When you have back bonding, it is a type of coordinate bond. And in order to make a coordinate bond, there are two things that you require. What are the two things that you require? You require an atom which should have lone pair of electron, and there should be another atom which should be having a vacant orbital. And the electrons can move. This can give electrons to the vacant orbital. So that is a condition in back bonding also. There should be an atom which must have, one species must have lone pair electron, another species must have vacant orbital. ठीक है? Now, ये तब होगा जब आपके पास already एक bonded एक molecule हो. For example, in the case of BF3. So in the case of BF3, you can see boron has how many electron around it? Boron has only 6 electron around it. P bonds, that means 6 electron, and there is one p orbital, that is pure p orbital, which is vacant. And the F atom, it has 3 lone pairs on it, and these 3 lone pairs can be given to boron, And that is why fluorine, all of these four fluorines are capable of donating or sharing a pair of electron with boron, and that is why stabilizing the boron atom. And in that case, once you are giving electron to the boron atom, boron will have 8 electrons, and that is why it will become more stable. Now, this is back bonding. So, what you should have in a molecule, there should be an atom which is having a lone pair electron, and there must be another atom which is having a vacant orbital. Now, the other condition is the size of atom should be small. Size of atom should be small. It should not be very large. Now, then we come to the extent of back bonding. Where is the back bonding most efficient? If I look at BF3, then in BF3, I can say that fluorine is an element of second period. That is why it will be having all the lone pairs in the 2p orbital. Similarly, boron is also of the second period, and that is why it will also having the vacant p orbital as 2p. And the overlapping between 2p and 2p orbital will be efficient because they are of the same size. As we go from BF3 to BCl3, I will have 2p, 3p. Then BBr3 will be 2p, 4p, and BI3 will be 2p, 5p. And that is what is going to happen. The extent of back bonding is going to decrease because of poor overlapping between the 2p subshell of boron and the subsequent subshells of halogen atoms. Now, if the back bonding is not efficient, तो हम क्या कह सकते हैं? सबसे ज्यादा efficient कहाँ पे? BF3 में. That means this BF3 is not as electron deficient as BI3. BI3 क्या हो जाएगा? It will be the most electron deficient. And when I talk about acids, acid is directly proportional to electron deficiency. And if I talk about base, then base is directly proportional to electron richness. So base is going to be always electron rich and acid is going to be always electron deficient. So be आपको electron deficient. If there is something which is very electron deficient, that means it is going to be an acid. So the lowest acidic strength, if I talk about the different halides of boron, then Bi3 will be the most acidic because it is not having back bonding. अगर back bonding नहीं है, that means it is electron deficient, followed by BBr3, followed by BCl3, and followed by BF3. Now, a few more examples that you can see. So one more thing you can see here, that both of these, the lone pair electron and the vacant orbital, the atom having lone pair and the atom having vacant orbital, both of them are having what? The p subshell. That is why, and we are making an extra bond. That is why it is a pi bond, and it is known as p pi back bond. What it is known as? P pi back bonding. Now there can be some cases in which you have the lone pair electron on the p orbital, and you are making a bond with the d orbital. So this is known as p pi d pi overlapping or p pi d pi back bonding. This D1 can only happen from third period and onwards, because second period elements, they do not have any D subshell. Now, in that case, you can look at an example of tricylyl amine. What is tricylyl amine? As you have trimethyl, methyl का मतलब होता है CH3, silyl का मतलब होता है SiH3. ठीक है? Silicon hydride is silyl. Now, when nitrogen is bonded with SiH3, nitrogen has a lone pair electron. Nitrogen के पास क्या होता है? It has a lone pair electron. Now, the silicon atom, it is of which? Tell me guys, it is of which group? Silicon. कौन सा period में है? It is below carbon, right? Below carbon means third period. ठीक है? It is with third period element. If it is with third period element, then it will have vacant d orbitals. It will have always vacant d orbitals, and the nitrogen atom can give the electrons on those vacant d orbitals. That is why the lone pair electron of nitrogen is shared between nitrogen and silicon, forming a back bond. But if I have CH3, that is methyl, this carbon atom is not going to have any. This carbon atom is not going to have any vacant d orbital. That is why that back bonding cannot take place. Achha. What is the consequence of this? There are two consequences. First of all, if there is no back bonding, then the shape of this element will be pyramidal. But if there is a back bonding, तब तो lone pair नहीं है. That is why it will become trigonal planar. It will become trigonal planar. The next consequence is that if there is no back bonding, then the lone pair of nitrogen is available. Lone pair of nitrogen is what? It is localized. It is available. It can act as a base. But the lone pair electron of tricylamine, it is not available because it is taking part in the bond formation. That is why it cannot act as a base. And that is why The trimethylamine is having basic character which is more than the trisilylamine. Why? Because the lone pair involves in back bonding. Similarly, agar aap case देखें, when you have CS3 hold twice an oxygen in the case of ether, and here you have silyl type of ether, then in that case what is going to happen? Because of back bonding, the effect of lone pair decreases and the bond angle is going to increase. ठीक है? So this is about back bonding. Basic यहाँ पे क्या है? Conditions आपको पता होना चाहिए कब back bonding हो रहा है, and consequence पता होना चाहिए कब back bonding. Back bonding का consequence क्या है? ठीक है? So please write this down. Let me know once you're done writing this. Let me know once you're done writing. Thanks. Done, everyone? Please let me know if someone is writing, or else I will move on. Okay, fine. Seems everyone is done. See. Next we have dimerization and polymerization. अच्छा, एक और चीज यहाँ पे देख लीजिए. Back bonding happens. Why does it happen? It happens because of electron deficiency, है ना? बोरॉन में जो हो रहा है, why it is happening? Because of electron deficiency it is happening. ठीक है? तो एक तो back bonding है जिससे electron deficiency खत्म हो सकती है. दूसरा क्या है? We can have dimerization. Now there are two types of dimerization. एक dimerization में हम लोग यूज करते हैं 3 centers and there are 2 electrons. जिसको बनाना बॉन्डिंग ही बोलते हैं, एंड देन वी हैव 3 सेंटर्स एंड 4 इलेक्ट्रॉन. इसमें कोऑर्डिनेट बॉन्ड, सिंपल कोऑर्डिनेट बॉन्ड यूज होता है. ठीक है? सो लेट अस फर्स्ट ऑफ ऑल लुक एट एन एग्जांपल ऑफ डायमराइजेशन of 3 center and 2 electrons and how does it happen. Please don't write anything down. Please just listen and see. We have boron, we have hydrogen, 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 boron, hydrogen, hydrogen and hydrogen. ठीक है? Now these are the 3 centers. Now essentially it was like this, BS3 and BS3, but these 2 electrons of boron and hydrogen, they started to share electron pair to this boron because boron is what here? Electron deficient. It is not having 8 electrons. So they also included this boron in their bond. Similarly, these 2, boron and hydrogen, they included this boron in their bond. So now you can see these 3 are making one bond, and there are 3 centers. That means boron is one center, hydrogen is another center, and this boron is another center. But the number of electrons in this bond, in this complete 3-centered bond, is only 2 electrons. And here, if you see, here also we have 3 centers. And how many electrons are present? There are 2 electrons are present. Okay? So we have 3 centered 2 electrons, and this is केस ऑफ डाइमराइजेशन यहाँ पे क्या होता है, इलेक्ट्रॉन की शेयरिंग होती है. Next, we have 3 centers and 4 electrons, in which you can see an example of BeCl2. In the example of BeCl2, please see, you have beryllium, beryllium. You have here chlorine, here chlorine, here chlorine, and here chlorine. So this is BeCl2, BaCl2. Now they are going to dimerize, and this chlorine, since it has lone pair electrons, it can donate to beryllium like this. This chlorine, it also has lone pair electrons. It can donate electrons to beryllium. Now in this case, how many electrons are present? You have this one center. Sorry. We have this one center, two center, and three centers. One electron, two electron, and this is also giving electrons. So these two electrons are present. So here we have how many? Three centers and 1, 2, 3, 4 electrons. So in three center, 4 electrons, we are going to have a coordinate bond, okay, or dative bond. Dative or coordinate bond. And in this case, we are going to have banana bonding. Okay. So banana bonding कब होगा जब lone pair electron नहीं हो. So you can see B2H6 hydrogen does not have, BeH2 hydrogen does not have any lone pair electron. Again, hydrogen does not have any lone pair electron. CS3 does not have any lone pair electron. Now, if you see 3-centered 4 electron, in all of these cases you are having halogen, and all the halogen they have lone pair electron. तो कहाँ पे 3-centered 4 electron है? तो if you have 3-centered 4 electron, then there must be an atom which is having lone pair electron. और अगर 3-centered 2 electrons वाला बन रहा है, that means there should be an atom which is not having lone pair electron. ठीक है? There should be atoms which should not be having lone pair electrons. Please write these down and also the examples, and write these two for the B2H6 and BeCl2. इसमें यहाँ पे लिख देता है अच्छे से dative bond. Dative bond is just another name for coordinate bond. Please let me know once you're done writing. Okay. When everyone is done. Next, we have oxy acids. Oxy acid, they will have a general formula. They're going to have a general formula of what? Ha, Zb, and OC. So oxy acids are acids of non-metals which also have oxygen. Acid है तो hydrogen तो होगा ही. Hydrogen will always be there. Yes, Hannah, this is banana bonding. This is banana bonding. Okay. So oxy acids, they will have hydrogen and the non-metal with an oxygen also. Okay. Now, how to remember different types of names of? एक सेकंड इसको अब रहने दीजिए. Oxidation state of central किसी और चीज का आ गया है यहाँ पे. This is basically how to form oxy acids. Oxy acids form होते हैं आपके पास ऑक्साइड से जनरली. ऑक्साइड में आप पानी डालिए, आपको क्या मिल जाएगा? ऑक्सी एसिड मिल जाएगा. I will give you an example. For example, आपके पास है SO2. सल्फर डाइऑक्साइड प्लस वाटर, यू विल गेट एन ऑक्सी एसिड। और अगर आप SO3 में वाटर डालिएगा तो आपको एक एसिड मिलेगा, ठीक है। Now what does it depend on? It depends on the oxidation state. So oxidation state of sulfur is what? +4 यहाँ पे. So in the product also, the oxy acid will also have a +4 sulfur. यहाँ पे it is +6. In the oxy acid also it will be having what? +6. So if you have SO2, तो कौन सा एसिड बनेगा? Please tell me guys. +4 oxidation state होना चाहिए. +4 and then +6. अच्छा, अच्छा किसी को नहीं आ रहा है? देखिए दो होते हैं, सल्फ्यूरस होता है और एक सल्फ्यूरिक होता है, ठीक है। इफ यू हैव इक ना, दैट मींस मैक्सिमम ऑक्सीडेशन स्टेट, ठीक है। इक का मतलब क्या हो गया? मैक्सिमम ऑक्सीडेशन स्टेट। और अस का मतलब हुआ जस्ट बिलो इक। तो यहाँ भी मिलेगा आपको सल्फ्यूरस एसिड और SO3 मिलेगा आपको सल्फ्यूरिक एसिड, H2SO4। एंड व्हाट विल यू गेट हियर? टेल मी गाइस। +4 oxidation state of sulfur. +4 oxidation state of sulfur. मतलब ट्राई तो कीजिए, क्या हो गया? यस, वेरी गुड अर्पित, करेक्ट। बस यहाँ से आप एक ऑक्सीजन निकाल दीजिए, +4 हो जाएगा, H2SO3, ठीक है। ये क्या हो गया आपके पास? दिस इज अस, विल बी जस्ट बिलो एक। एक में से आप दो निकाल दीजिए, आपको क्या मिल जाएगा? अस मिल जाएगा। उसी तरह से सोचिए, फॉस्फोरस एसिड एंड फॉस्फोरिक एसिड। Tell me what will be the formula of phosphoric acid? And what will be the formula of phosphorus acid? Phosphorus का मैक्सिमम ऑक्सीडेशन स्टेट का होता है +5, तो यहाँ पे होगा +3। हाँ, वेरी गुड अर्पित। दिस इज फॉर एक है या अस है अर्पित? जोर से बोलिए जरा।
फॉस्फोरिक एसिड।
फॉस्फोरिक एसिड, हाँ वेरी गुड, करेक्ट। देन राइट द फॉर्मूला फॉर फॉस्फोरस एसिड। ठीक, दिस इज द जनरल फॉर्मूला ना, इसमें आप लोग बैठाइए, +5 होना चाहिए। ऐसे देखिए, फॉस्फोरस हो गया एक आपके पास, ठीक है। ये 1 फॉस्फोरस, आपने डाला एक ऑक्सीजन, कितना हो गया? +2। आपने डाला 2 ऑक्सीजन, कितना हो गया? ठीक है, ओके। देखिए गाइस, प्लीज आंसर मी इन दिस पार्ट, ओके। अगर आप लोग को फॉर्मूला, एक तो फॉर्मूला याद होना चाहिए ना, फॉस्फोरिक एसिड, फॉस्फोरस एसिड, सल्फ्यूरिक एसिड, सल्फ्यूरस एसिड, इन सबका फॉर्मूला। ओके ओके, नो प्रॉब्लम अरिता, यू शुड रिमेंबर दिस फॉर्मूला। बट इफ यू डोंट नो, देन हम आपको बता रहे हैं किस तरह से इसको आप लोग लॉजिकली ला सकते हैं। बस ये याद रखिए, फॉस्फोरिक इज व्हेन यू हैव मैक्सिमम ऑक्सीडेशन स्टेट। मैक्सिमम ऑक्सीडेशन पता होना चाहिए आप कि फॉस्फोरस मैक्सिमम ऑक्सीडेशन कितना हो सकता है? द नंबर ऑफ वैलेंस इलेक्ट्रॉन, दैट इज 5। मिनिमम कितना हो सकता है उसके पास? 3 हो सकता है। मिनिमम तो नहीं, उसके जस्ट एक बिलो कितना हो जाएगा? +3 हो जाएगा। सो एक विल बी मैक्सिमम और अस विल बी जस्ट बिलो एक, ठीक है। तो फॉस्फोरिक के जस्ट बिलो, यानी कि 2 कम कर दीजिए तो क्या मिल जाएगा आपको? फॉस्फोरस एसिड मिल जाएगा। नाउ आई एम टेलिंग यू हाउ टू गेट दिस फॉर्मूला। फॉस्फोरिक एसिड में +5 आपको चाहिए। नाउ यू नो दैट ऑक्सी एसिड हैव अ फॉर्मूला H, देन नॉन मेटल एंड देन ऑक्सीजन। पहले आप नॉन मेटल को ले आइए, फॉस्फोरस हो गया, you add one oxygen atom. Now phosphorus is +2. ठीक है, आप 2 ऑक्सीजन एटम ले आइए, कितना हो जाएगा? +4 हो जाएगा. ठीक है, +4 नहीं, कितना चाहिए? +5 चाहिए. Now, in order to get +5, you have to have one more oxygen. अब कितना हो गया? +6 हो गया, राइट? इट इज नाउ +6. अच्छा, अब यहाँ पे क्या कर सकते हैं आप? यहाँ पे आप एक क्या डालना चाहेंगे? आप यू विल ऐड वन हाइड्रोजन हियर. ठीक है, इज इट +5 नाउ? Is it +5 now? Yes or no? Please tell me. तो आप कुछ जवाब नहीं दीजिएगा तो कहाँ से होगा? चलिए याद कीजिए, फिर आप लोगों के लिए कुछ नहीं है. इसमें लिखिए H3PO4, इसमें लिखिए H3PO3. Phosphoric acid and that is phosphorus acid. अब कोई ऐसे बोल देना आपको POH होल थ्राइस एंड कोई पूछ ले एसिड है या बेस है, तो मत बोल दीजिएगा बेस है OH देख के. इट इज एन एसिड. ओके, प्लीज रिमेंबर वन थिंग. Hydroxides of metals are basic and non-metals are acidic. ठीक है, अब ये क्लास 10th वगैरह की बातें हो गई. Hydroxides of metal are basic and non-metals are acidic. Okay. So I hope all of you have written this now. Phosphoric acid, phosphorus acid, sulfuric acid, sulfurous acid. Now moving on, how to have this different type of acid which is having prefixes such as pyro, meta, and then you have peroxy acid and then you have hypo acids. Now, in case of pyro, you need to have 2 moles of the oxy acid and then remove a water molecule. हम बता देंगे, इसको पहले लिख लीजिए. ठीक है. In meta case, what you need to have, you should have 1 mole of oxy acid and उसमें से पानी निकाल दीजिए and you remove water from that. Per oxy acid में you will have O double bond O. इस टाइप का बॉन्डिंग होगा आपके पास. You will have O double bond O. In case of hypo, if you have us or if you have एक acid, sulfurous हो चाहे sulfuric हो, phosphorus हो चाहे phosphoric हो, if you remove one oxygen atom, then you are going to get what? Hypophosphoric acid, hyposulfuric acid, hypophosphorus acid, this type of thing. Okay, so please write this down. Let me know once you're done. And then we will see how to use these things. कि pyro है तो क्या करेंगे, meta है तो क्या करेंगे, and so on. Let me know once you're done writing. Done everyone? Okay. Before doing pyrosulfuric acid, यहाँ पे आप लिखिए when an oxy acid has when an oxy acid has 2 sulfur. ठीक है, जब ऑक्सी एसिड के पास क्या हो, 2 सल्फर एटम हो एंड द नंबर ऑफ ऑक्सीजन इज लेस देन 7, तो आपके पास कैसा बॉन्ड होगा, एस बॉन्ड होगा. If number of oxygen atom is equal to 7, then you will have SOS bond. If the number of oxygen atom is 8 or greater than 8, then you will have SOOS bonds. ठीक है, you will have SOOS. पर ऑक्सी बॉन्ड होगा यहाँ पे. So before going to pyrosulfuric acid, हम लोग पहले H3PO3 सिंपल मॉलिक्यूल्स को कर लेंगे, उसके बाद फिर pyrosulfuric acid का. ठीक है, all if you write this down. O, if it is less than 7, then SS bond. If you have O that is greater than 7, sorry, equal to 7, then SOS, and if it is equal to 8 or greater than 8, then it is going to have SOOS bonds. ठीक है, now please let me know once you're done. उसके बाद फिर हम आगे आपको समझाएंगे what is this part. Please let me know once you're done. Per oxy bond. ठीक है, this is per oxy bond. Let me know once you're done. Done everyone? Yes or no, please tell me. Is everyone done?
Yes, sir.
Yes. अब यहाँ पे देखिए, this 3 things is what you need when you are making the structure of an oxy acid. ठीक है, सबसे पहले आपको phosphorus लेना है, and what I have said, make this Z is a non-metal, right? Make at least 1 double bond O and 1 OH bond. पहले एक आप डबल बॉन्ड O कर लीजिए और उसके बाद एक OH कर लीजिए, इतना कर लीजिए. उसके बाद आप देखिए, make maximum number of ZOH. ठीक है, फर्स्ट स्टेप हो गया. Now you tell me, can we make any other OH bonds? Do we have oxygen and hydrogen both remaining? Do we have oxygen and hydrogen both remaining? बताइए, how many oxygens are there remaining? How many oxygens are remaining? 2 लगा लिया आपने, कितना बचा है और?
1.
1. And remaining hydrogen is equal to how much?
2.
2. ठीक है, यानी कि I can make 1 OH bond. सही है, एक ऑक्सीजन यूज कर लिया, एक हाइड्रोजन यूज कर लिया. करेक्ट? यस और नो, प्लीज टेल मी गाइस. अब क्या बचा है? नाउ यू हैव जस्ट व्हाट, यू कैन नॉट मेक एनी मोर OH, और OH बन नहीं सकता. व्हाई? बिकॉज ऑक्सीजन खत्म हो गया. अब क्या बचा है? सिर्फ एक हाइड्रोजन बचा है, तो हाइड्रोजन के साथ एक बॉन्ड, सिंगल बॉन्ड. ऑल इफ यू गॉट दिस, यस और नो, प्लीज टेल मी.
Yes.
Yes, sir.
खुद से बनाइए इसको जिस तरह से हमने बताया था. First of all, start with double bond O and 1 OH bond. Then you have to make maximum number of OHs, और उसके बाद अगर आपके पास हाइड्रोजन बना है तो सिंगल बॉन्ड, and if you have remaining oxygen, then there will be a double bond. Done? ठीक है. Now H2SO4 का बनाइए. H2SO4 का बनाइए and then tell me number of sulfur double bond वो कितने हैं H2SO4 में and number of OH कितने हैं sulfur bonded to OH. How many double bond O and how many OHs are there? First of all, make the structure है ना, इतनी जल्दी नहीं आएगा आंसर. Yes, Marita correct. Sania correct. Very good. Yes, Anna correct. Arpit correct. Alia correct. Very good. Yes. So first of all, you will start with sulfur double bond O, and you will make one OH. So now we will say remaining hydrogen is how much and remaining oxygen is how much. Remaining hydrogen is 1. Remaining oxygen is also 2. Remaining oxygen is 2. Yeah, 2 is done now. So I will make one OH. Hydrogen is done. I have remaining one oxygen. So double bond O. All of you got this? Yes or no? Please tell me.
Yes, sir.
ठीक है, अब देखते हैं पायरोसल्फ्यूरिक एसिड. ओके, पायरोसल्फ्यूरिक एसिड. व्हाट इज पायरोसल्फ्यूरिक एसिड? पायरोसल्फ्यूरिक एसिड का मतलब सबसे पहले आप ले लीजिए सल्फ्यूरिक एसिड. प्लीज अब यहाँ पे देखिएगा, ठीक है. You take sulfuric acid. What is sulfuric acid? H2SO4. Take 2 moles of H2SO4. तो कितना हो जाएगा ये? H4, S2 and O8. सही है? Yes or no? Please tell me. अब पायरो है तो क्या करते हैं? 2 मोल लेके उससे क्या निकालना रहता है? You have to remove 1 water molecule, right? हाँ, very good. आप इससे क्या निकाल दीजिए? एक H2 निकाल दीजिए. So you have to remove 2 hydrogens. कितना हो गया ये? H2. Sulfur will be 2 and oxygen will be O7. Now you have 2 sulfur and oxygen is 7. तो कैसा बॉन्ड होगा? What type of bond? SOS, SS या फिर SOOS? Tell me guys.
SOS.
SOS होगा ना? Oxygen is equal to 7. तो कैसा होगा? SOS. ठीक है? So you will have SOS bond बना दीजिए आप. Now what you need to do? दोनों सल्फर में एक डबल बॉन्ड O and one OH. Now you tell me, is there any hydrogen remaining, oxygen remaining? Hydrogen बचा है कुछ? Tell me. Is there any hydrogen remaining? No, there is no hydrogen remaining, right? So how many oxygens are remaining now?
2.
2 oxygens.
2.
This sulfur will get 1 oxygen. This sulfur will get another oxygen. Understood this? Yes or no? Please tell me.
Yes, sir.
Try this phosphorus acid. Pyrophosphorus acid. तो here also we have pyroform, तो यहाँ पे कैसा होगा, POP होगा, ठीक है। And from here you can make now. You have to tell me number of P double bond O, number of POH. POH bond, okay. One POP. Yeah, I think that is correct. Oh, wait a second. It is pyrophosphorus acid, not phosphoric acid.
Okay, sir.
So what will be phosphorus acid?
H3PO3.
H3PO3.
Very good, H3PO3. So twice of H3PO3, it is going to be H6P2O6. And remove a water molecule, you will have H4P2O5. ठीक है? So it is pyro, तो यहाँ पे POP होगा. Double bond O, one OH, another OH. What is the meaning now? Our oxygen is done, phosphorus is done, only hydrogens are remaining, right? How many hydrogens? 2 hydrogens are remaining. So एक hydrogen यहाँ पे, दूसरा hydrogen यहाँ पे. Number of P double bond O is going to be 2. Number of POH is also going to be 2.
सर इसमें SS बॉन्ड नहीं होगा सर, वो 5 है।
Sorry?
सर इसके अंदर SS बॉन्ड नहीं होगा सर, क्योंकि वो तो 5 है ना सर इसमें।
नहीं, that is only for sulfur. When oxyacids have 2 sulfur.
Okay, sir.
ठीक है? Now also write a note.
Sir, then how did we decide that we have POP bond?
देखिए, what do you think? ये जो हमने आपको ये ट्रिक बताया है, this is before the structure or yeah after the structure? Once you look at the structure, then only you can see some patterns, right? तो स्ट्रक्चर से वी हैव गॉट दिस, अगर O 7 से कम है तो SS होना चाहिए, O अगर 7 के बराबर है तो SOS होना चाहिए. इट्स नॉट द अदर वे अराउंड. ऐसा नहीं कि O 7 है तो SOS है. SOS कब था? जब O 7 था. ठीक है? सो दिस इज जस्ट अ ट्रिक, इट इज नॉट अ रीजन. अब कंप्लीट केमिस्ट्री इज फैक्चुअल. अब जो है सो है. ठीक है? यू गेटिंग माय पॉइंट?
Yes, sir.
ठीक है? So these things ना O is less than 7, O is equal to 7, ये कोई भी अगर बता रहा है आपको, then he has looked at the pattern and structure देखने के बाद वो बता रहा है, किसी रीजन की वजह से नहीं है कि वो 7 है तो SS ही हो रहा है, ऐसा कुछ ये नहीं है उसमें. It's just that SS bond was seen and SS bond was found whenever the number of oxygen atom was less than 7. तो हमने बोल दिया कि इसको याद कर लीजिए आप, ठीक है. Now basically आपके पास pyro अगर रहेगा ना तो pyro में you will have ZO type of bond generally speaking. So write a note here. Note is regarding oxy acids of group 2, sorry, not group 2, period 2. Oxy acids of second period element can't have लिख लीजिए, can't have more than 8 electrons on central atom. ठीक है. For example, HNO3, nitric acid. Now, अगर हम, if I talk about the sequence or the algo that we are using to form the structure, तो हम क्या करते हैं, नाइट्रोजन में एक डबल बॉन्ड O बनाते हैं, उसके बाद एक OH बना देते हैं. Now I can see that there is one oxygen remaining, so I would have added a double bond O according to whatever we have seen till now. But if I add double bond O, it will be having 5 bonds and there will be 10 electrons in the valence shell of nitrogen, which is not possible because nitrogen only has second shell, and second shell can accommodate only 8 electrons. That is why this structure will be wrong. Rather, this nitrogen will be making a coordinate bond with oxygen like this. अगर आप अब देखिए, now it has 4 bonds, and यहाँ पे भी उसके बाद यहाँ पे पॉजिटिव चार्ज आएगा और यहाँ पे एक नेगेटिव चार्ज आएगा, because oxygen is taking electron, it will be negative, and nitrogen is giving electron, it will be positively charged. There will be a coordinate bond, and in this type of case, this complete structure is neutral. एक ही स्ट्रक्चर में क्या आपके पास पॉजिटिव और नेगेटिव आए हैं, that means it is a neutral structure. ठीक है. And there is a coordinate bond. So there are two ways of writing this. You can either show a coordinate bond like this, तब आपको charges दिखाने की जरूरत नहीं है, and or you can have something like this, nitrogen with a double bond OH and single bond oxygen like this. If you're writing single bond oxygen, then you have to write plus and then minus here. Okay. So there are two ways in which you can show nitric acid. Please write this down. And see next, we have oxy acids of halogen. Oxy acid of halogen, if you start with oxy acid of halogen, you will start with OH. Halogen can form one bond, है ना? Generally speaking, कितना bond बनाता है? One bond. That's why you will have hypohalous acid. Hypo का मतलब होता है क्या? एक कम हो गया. क्या कम हो गया? एक ऑक्सीजन कम हो गया. ठीक है. Hypo का क्या मतलब होता है? One oxygen less. हालस में जाएंगे तो क्या हो जाएगा? एक ऑक्सीजन ज्यादा हो जाएगा. दैट मींस यू विल हैव डबल बॉन्ड O. हालस से फिर आप हैलिक जाइएगा तो क्या हो जाएगा? एक और ऑक्सीजन आ जाएगा. पर हैलिक जाइएगा तो एक और ऑक्सीजन आ जाएगा. ठीक है. तो प्लीज रिमेंबर, सिर्फ और सिर्फ किसका खेल है? ऑक्सीजन का खेल है. If you see here, OH is still same. OH यहाँ पे भी एक OH है. Here also we have one OH. Here also we have one OH. Here also we have one OH. हाइपो में है, you have zero oxygen, zero double bond O. यहाँ पे आपके पास one double bond O है. Here you have two double bond O, and per halic में three double bond. Okay. And as the number of oxygen atom is increasing, the oxidation state is also increasing. Please write this down with examples. Done everyone? Is going to please tell me. Please let me know once you're done. Anji, is everyone done? चलें आगे.
Yes, sir.
Okay. Now please write this. When oxyacid contains SS type of linkages, then there are two types in that case. When you have polythio, so this is NOUS होगा. Okay, and then you have polythionic acid. So polythiosulfuric acid, sulfurous acid. ठीक है उस तरह से. Now, if you have, you will be given H2SNO4, H2SNO6. SNO4 है तो oxidation state is +3. O6 है तो it is +5. And if you have O6, then it is going to be what? Ic acid. And अगर O4 है तो you will be having us acid. ठीक है, first thing is that. Now the question that comes is the number of SS linkages that we have. So number of SS linkage is equal to number of sulfur atom minus 1. Okay. For example, if I have, let us suppose H2S3O4. Now, in this case, what we are going to do? In this case, we are going to write number of SS linkages will be equal to 3 minus 1, that is equal to 2. Sulfur, single bond sulfur, single bond sulfur. So एक S linkage हो गया और यहाँ पे दूसरा S linkage. ठीक है? Please write this down. Now, moving on to the acidic nature of oxyacid. Okay. So in general, when you have same element, for example, आपके पास है sulfurous acid, sulfuric acid, and so on, then when you have the same non-metallic atom, then the acidic nature of oxyacid is directly proportional to the oxidation number of the active element. यानी कि active element क्या हो जाएगा यहाँ पे? Active element is going to be the non-metal. So if I take the case of halogen, then in the halogen's case, perhalic acid is most acidic, followed by halic, followed by halous, and then we have hypohalous because the oxidation state is increasing from hypohalous to perhalic acid. As the oxidation number increases, the acidic nature also increases. But if you are going to have different oxyacid, then the acidic nature is going to directly proportional to the electronegativity. What is En? En is electronegativity. Electronegativity of the different elements. ठीक है? अगर हम यहाँ पे बात करें आपके पास, if I have HClO3, HBrO3 and HiO3, oxidation state सब क्या है यहाँ पे? +5 ही है. But what is going to be the most acidic? Which is the most electronegative here? So chlorine is most electronegative, then bromine, then iodine. So this is going to be the order. Chlorine is ज़्यादा acidic nature, then you have bromine, and then you have iodine. ठीक है? चलिए, please write this down. And exception is that for oxyacids of phosphorus, the acidic nature is inversely proportional to the oxidation number. It happens because the remaining oxygen atom, for example, if I take H3PO2, so H3PO2 will be P double bond O, OH and 2 hydrogens. If I will remove a hydrogen atom from here, I will get O negative. Okay. So once I get O negative, now this negative charge is completely delocalized because यहाँ पे एक इलेक्ट्रॉन आ जाएगा, यहाँ पे ये चला जाएगा. So it is between these two oxygens. But अगर हम H3PO3 की बात करते हैं, then in that case this phosphorus atom, it is having double bond O. Then it also has OH. अभी क्या हो जाएगा इसके पास? S3. I can have one more OH, right? I can have one more. Yes, one more OH, and then you will have one hydrogen. ठीक है, सही है. H3PO3. ठीक है. If I remove one hydrogen from here, I will get a negative charge here. ठीक है, I will get a negative charge here. Now, if you look at here, this oxygen atom is also having lone pair electrons. अगर इस oxygen के atom के पास lone pair electron है, then this can also go into resonance, and this negative charge can also go into resonance like this. And now, since this negative charge is sometimes in resonance and sometimes not in resonance, that is why what happens. That is why यहाँ पे आपके पास क्या हो जाता है? You have cross resonance, which decreases the stability of the conjugate base. And if this is not stable, तो क्या होगा? The acid is not going to be having higher acidic nature. ठीक है? So only for oxyacids of phosphorus, this is the case. Please write this down. बाकी में ऐसा नहीं होता है. Why? Because they have only one OH bond. ठीक है? Generally जहाँ पे आपके पास एक OH bond होगा, then it is going to be the best acid. Write this down. Let me know once you're done. Oops. Yes, I hope everyone is done. Now let us look at hydrolysis. What is hydrolysis? We are breaking down something using water. Okay, hydro means water, lysis means breakdown. The hydrolysis of water, you will see many reactions. ठीक है, लेकिन ऐसा नहीं कि सारे reactions आपको रटने पड़ेंगे. It is a simple case of nucleophilic substitution reaction and also nucleophilic substitution by molecule. SN2 का एक example है what? It is hydrolysis. All the hydrolysis is what? Nucleophilic substitution. Nucleophilic substitution में क्या होता है? There is an electron rich species जिसको हम nucleophile बोलते हैं, and nucleophile attacks on electron deficient species. ठीक है, किसमें अटैक करता है? Electron deficient. Now, electron deficient क्या हो सकता है? Electron deficient can be something which is having vacant orbital. Right? It should have what? It should have at least a vacant orbital होना चाहिए. जो दूसरी चीज क्या है? अगर SN2 हो रहा है, that means it should not be crowded. ठीक है. Now from here we will start slowly understanding what is the reaction. Please इसको ना इस तरह से देखिएगा. You have RCl plus H2O gives you ROH. ठीक है. क्लोरीन निकल रहा है, OH ऐड हो रहा है. Simply speaking, यहाँ पे देखिए BeCl2 आपने water add किया, you get instead of the 2 chlorines you get OHs. And why is the water molecule attacking on beryllium? It is attacking on beryllium only because beryllium is having a vacant orbital. It is not, it is what it is, electron deficient, उसके octet complete नहीं है. Similarly, if you look at BCl3, here also the chlorine is replaced by OH. AlCl3, chlorine is replaced by OH. SiCl4, chlorine is replaced by OH. ठीक है? And after heating up, you are going to get SiO2. ठीक है? SiOH4 मिलता है, but after heating up, you are going to get SiO2. Next, you see the case of SF6. Now, since sulfur, you have hexafluoride, this is going to be having what? A very crowded structure. ठीक है? And that is why OH negative does not have any place to attack on the sulfur atom. अब लिखा सर सल्फर का तो लेकिन ऑक्टेट कंप्लीट है, क्यों अटैक कर रहा है यहाँ पे? Yes, the octet of sulfur is complete, but sulfur has vacant 3d orbitals, है ना? इसके पास d orbitals vacant है, that is why oxygen can attack here. ठीक है? There is one important thing that should be present, the vacant orbital. और उसी vacant orbital पे कौन अटैक कर रहा होगा? Nucleophile will be attacking on that atom which has vacant orbital, ठीक है? Next, if you see the case of CCl4, then in that case, what you will see that there is no hydrolysis at ordinary conditions. Again, if you are going to heat it up, then in that case, OH will not attack on carbon. वो कहाँ attack करेगा? Chlorine भी attack करेगा, because chlorine has vacant orbital and carbon does not have vacant orbital. ठीक है? Now, if you see these cases also BF3 and all of these things, then it is going to be the similar cases. ठीक है? अब यहाँ पे बस जो changes है, that is between complete hydrolysis and there is partial hydrolysis. ठीक है? So you have to remember these cases for partial hydrolysis. Okay. Now, this is not important. The next example is very important. NF3. NF3 में nitrogen, it does not have any vacant orbital because it has 3 bonds. 6 electron वहाँ हो गए. Lone pair of electrons in nitrogen, that means 8 electron. Now again, fluorine also does not have any vacant orbital because it is in the second period. And that is why OH cannot attack either on nitrogen or on fluorine, and that is why no hydrolysis happens. But if I take the case of NCl3, the NCl3 में कहाँ पे attack होगा? Water can attack nitrogen? No, it cannot attack nitrogen because nitrogen does not have any vacant orbital because it is present in the second period element. But chlorine has vacant orbital, and that is why oxygen, the hydroxide, it attacks on chlorine and forming what? Chlorous acid, है ना? Halous acid, hypohalous acid बना रहा है, hypochlorous acid. Then in the next case, if you have PCl3, तो PCl3 में कहाँ पे अटैक करेगा? PCl3 में अटैक करेगा ये phosphorus में, right? Because phosphorus is not going to have as many lone pair as chlorine is having. तो यहाँ पे किस पे अटैक कर रहा है? Phosphorus पे अटैक करेगा, and that is why you are going to get S3PO3. You are going to get S3PO3. Similarly, in the case of ASCl3, now when you have SPCl3, BiCl3, and then you are going to have PCl5. PCl5 में क्या होगा? Again, because of crowding, there will be partial hydrolysis, and then POCl3 will be again hydrolyzed to get H3PO4. One more thing that you should remember, that the extent of hydrolysis is directly proportional to covalent character. If you have more covalent character, then there will be complete hydrolysis. If you have less covalent character, just say for example you have BiCl3, then in that case you are having partial hydrolysis. Okay. Next, please see hydrolysis of higher covalent character containing molecules. In सब में भी आपको देखिएगा, it is again very easy. You have beryllium, you have magnesium, you have calcium, you have aluminium, you have manganese, you have aluminium, calcium, lithium, and calcium. ठीक है? In all of these cases, what is happening? If you see, if you add water, तो beryllium में क्या हो रहा है? Beryllium is getting converted to BH, OH whole twice. यहाँ पे +2 था, यहाँ पे भी +2. ठीक है? So in these cases, it is very easy. Then you have to remember for hydrolysis of interhalogen compound. Now, interhalogen compound are of 4 types. You can have, for example, आपके पास है ICL. ठीक है? So you have this one compound, ICL. Then you can have ICl3, or you can have IF5, IF7, these type of compounds. Now, if you have AX type of compound, तब यहाँ पे क्या होने वाला है? Then you will get HX, and what is this HOA? This is hypohalous acid. अगर AX3 है, तो HX मिलेगा, and then you will get halous acid. If you have AX5, then you will get what? You will get HaO3, that means halic acid. And if you have X7, then you are going to get what? Then you are going to get perhalic acid. ठीक है? So एक तो आपको HX सारे केस में मिलेगा, you will get HX, HX, HX. ठीक है? This X is going to be what? HX. And then if you have 7, then it will be having HA4. ठीक है, नेक्स्ट वी हैव द हाइड्रोलिसिस ऑफ ग्रुप 18 एलिमेंट्स, ये आपको याद करना पड़ेगा, बिकॉज इसमें हम ये नहीं कह सकते दैट इट इज गोइंग टू बी वेकेंट, यहाँ पे कोई वेकेंट ऑर्बिटल और इलेक्ट्रॉन डिफिशियंसी का सवाल ही नहीं, ठीक है। चलिए, सो प्लीज राइट दिस एंड इफ यू हैव एनी डाउट प्लीज लेट मी नो। यहाँ से लिखना चालू कीजिए। दीज थिंग्स आर इंपॉर्टेंट, ठीक है ना, इसको दिमाग में रखिएगा हमेशा। शायद इतनी जल्दी आपको ये सारे रिएक्शंस तो नहीं याद हो पाए, लेकिन ऑलवेज रिमेंबर, कभी भी हाइड्रोलिसिस का सवाल हो तो व्हाट इज द वेकेंट ऑर्बिटल। Write this down, let me know once you're done. I'm giving you guys 3 minutes for this. 4 मिनट ले लीजिए, it's too much. Is everyone done?
No, sir.
Acha. Take 2 more minutes. Done.
Done, sir.
Now write this. Okay, one more thing. आप लोग at least ना ये पूरा एक reaction पढ़िए एक साथ and then write it down. ऐसा नहीं कि BE2 C2 then you are looking at the screen plus then you are looking at the screen 4H2O 4H2 then you are looking at screen. इतना मत, ठीक है? एक बार पढ़िए BE2 and then you have carbon plus 4H2 is going to give you 2 beryllium hydroxide and methane. ठीक है? इस तरह से कीजिए. Also try to find a relationship between these things. I hope you can see that. Yes, everyone done? All of you wrote this? We can move on to the next topic, that is inert pair effect. Ja, ठीक है. Hope everyone has written this down. Now please see. We'll understand inert pair effect using an example. ठीक है. If I take the electronic configuration of bismuth, then the electronic configuration of bismuth is, we have xenon, then we have 6s2, 4f14, 5d10, and 6p3. Okay, we have 6p3. Achha. From bismuth is in the nitrogen family, and if I take the electronic configuration of nitrogen, then what is nitrogen? Nitrogen is going to be 1s2, 2s2, 2p3. Okay. Now let us look at the valence shell here. Here we have the valence shell, that is 6s2 and 6p3. Here if you have the valence shell 2s2 and 2p3. Looking at the valence shell, we can say that it is having 5 electrons. Out of the 5, there are 2 electrons in the s subshell and there are 3 electrons in the p subshell. S में है 2 और p में आपके पास 3. And because of this, you can have 2 variable oxidation state. It can either show +5 or it can also show what? +3 oxidation state. Okay, +3 oxidation state. Now, inert pair effect says that as we go down the group, the reluctance of S subshell appears in taking part in bond formation. क्यों ऐसा होता है? Please see what is happening here. If I look at these S electron of bismuth, this S electron is having 4f and 3d, 4f and 3d, which are not able to, which will not be able to shield the 6s electron effectively. 4f, because f subshell and d subshell की क्या होती है? Shielding capacity बहुत कम होती है. That is why it is not effectively shielding 6s electron from what? From the nuclear charge. From the effective nuclear charge, the positive protons that we are having, and since s subshell is nearest to the nucleus, this s subshell will be attracted towards the positive charge very effectively, and that is why this s subshell electron will not take part in bond formation. But can we say the same thing for nitrogen? No, we can't say the same thing for nitrogen. Why? Because nitrogen के पास S के बाद you don't have anything which is hindering or which is having any shielding. Okay? And that is why what happens, both of these electrons will be available, all of these electrons will be available for bonding. But bismuth में क्या होगा? Nitrogen हो गया, even phosphorus के case में क्या होगा? You don't have any electrons in between S and B. That is why there is, वहाँ पे, यहाँ पे तो poor shielding है, right? Here we have what? Poor shielding. That is why S electrons are being, X electron subshells are being attracted by the nucleus. यहाँ पे shielding कौन कर रहा है? 1s2 का, and 1s orbital का shielding क्या होगा? It will be very effective. ठीक है? That is why what happens? Please write inert pair effect में the reluctance of ns electron, the reluctance of ns electron to take part in bond formation. Okay, that is known as inert pair effect. And what is the consequence? The consequence is that the stability of lower oxidation state increases down the group. As we go down the group, ns electron will not take part in bond formation. अगर ns electron are not taking part in bond formation, तो क्या होगा? Oxidation state गिर जाएगा. And that lower oxidation state will be having higher stability down the group. Okay, that is why if I have antimony +2 and antimony +4, है ना? You have two cases. आपके पास है, sorry, you have 10 + 2 and you have 10 + 4. 10 is in which group? It is in carbon, na? कैसे गीत सुनाओ प्रभु? Yeah. So you have 10 + 2 and 10 + 4. In that case, 10 + 2 is going to be more stable than 10 + 4. Similarly, bismuth +3 will be more stable than bismuth +5. But if I talk about phosphorus, and since phosphorus is above, यहाँ पे क्या होगा? +5 is more stable than +3. इसका consequence क्या होगा? इसका consequence ये होगा that bismuth +5 से bismuth +3 जाना, it will be spontaneous. It will be very easy. Why? Because bismuth +3 is stable. अच्छा, +5 से +3 कैसे जाएगा? It can go from +5 to +3 only by eating 2 electrons. So bismuth is what? Bismuth is getting reduced